All right. Thank you for watching this video. Been a minute since I made a video. This video is going to be on compound inequalities. Just short. I shouldn't say short. I don't know how long this is going to be, but this is an introduction video into compound inequalities. So I'm going to go through some notes and then some step-by-step example problems that I feel like are pretty similar. There's certainly ones that I'm giving to my students. Okay, so compound inequalities, just like in English class, when you learn about what a compound sentence is, it is combining more than one inequality. Compounding. We're compounding it. We're combining more than one inequality. So in the case of algebra 1, usually you're combining two. So we're going to combine using the word and we're going to combine using the word or. Now, I talked with my students earlier today, and they came up with some things that they like that they seem to understand the word and by. And to them, and means both. And another student said that it means also. I think somebody else said means to include. And then for or, they said either, and or this or that. So compound inequalities, we're going to be using these words where and means both, also, or means either, or this or that. So let's get into it. So I've written down an example, two examples of compound inequalities. This one is a compound inequality that's combined with the word and this one is a compound inequality with the word or, combined with the word or. So first thing, the first key difference. Well, actually, let's just get into graphing them. So when you're doing a compound inequality, the best way to graph these is to, above the number line, sketch a graph of each individual inequality, because this is two separate inequalities that's being combined into one. So if I were to graph this above, and actually let me get out another color also. Yeah, that'll be good. X is less than 2. So let's actually put in a keynote above. If you do not know your open and closed circles, I'll add this in. So less than or greater than. These are open circles. All right, and then less than or equal to and greater than or equal to, these are closed circles. Okay, so for this is an open circle, and we're going to put an open circle above 2. So we're going to put an open circle above 2. And as this reads, this is x is less than 2. So it's getting more negative. So x is less than 2. All right. Now for this one, that's a greater than or equal to symbol. So that's a closed circle. And I'm going to put it above -3. All right. And now that's getting greater than -3. So it's getting more positive. Now the word and means both. So the inequality has to be working for both of the inequalities that are being combined. Where is it happening for both of them? And where it's happening for both of them is it's happening for both of them in between or where they overlap here. That is where they overlap. That is where all these solutions in between would satisfy both of these. They would solve both of these inequalities. If I plug in -2, is -2 less than 2? Yes. Is -2 greater than or equal to -3? Yes. Is 1 less than 2? Yes. is 1 less than -3? I mean, not less than, greater than or equal to -3. Yes. So everything in this, in between these 2 points, not including 2, but including -3, because we include -3, but not including 2, all of these values, there's an infinite amount of numbers in between here. You do -2.99999, whole bunch of different stuff, tons of different answers, but all of them, anything that is in between here and here, satisfy both of these. That's what the word and means. All right. I'm going to note that down here. The overlapping area. Okay, the overlapping area is the area that you graph or that contains all the solutions to the compound inequality when we're talking about the word and. We're talking about a compounded and where we need to satisfy both simultaneously. They need to be solved. Every solution, every value that we pull out has to solve both. Also, both, also, including both of them. Okay, I think you get my point. Now, there's one other special thing about a compounding or a compounded inequality that uses the word and that is that we can write it in a more simple way. We can take these 2 separate inequalities and combine them. And what you do is you take the more negative number, you put it on the left side. You take the more positive number, you put it on the right side. And then you put x in the middle, or your variable, whatever your variable is, in the middle. And we take the symbols. So what symbol is this? This is x is greater than or equal to 3. So I'm going to say x is greater than or equal to -3. This one says x is less than 2. So x is less than 2. If you make sure that your negative number, your more negative number, is on the left side, and your more positive numbers on the right side, your arrows, your inequality symbols will always point towards the left. They always point towards the more negative number. If it doesn't, then it doesn't work. Then it's not true. There's probably not going to be no solution. The thing's going to blow up. So for a compounded inequality that has the word and, you can combine it to be a single inequality instead of 2 separate little ones that you then graph and overlap. Because this should match up, right? Oh, I see -3 right there. Oh, -3. I see 2 right there. Oh, 2 right there. And then it's in between them. I like this a lot better. I prefer my students to write this, not this. I want them to write this. And yeah, like I said, the more negative number on the left, the less negative number on the right, then no matter what, all of your inequality symbols should be pointing towards the left. If they're not, something's wrong. Shouldn't work. Okay, moving on. Let's go over to the or one. So, x is greater than 3. Greater than symbol means open, and it's getting greater than. Or x is less than 0. Less than, open circle, and then less than. Now there's no overlapping area here, but the key word or means that we don't have to satisfy both of them. Not what we pull out doesn't have to be a solution to both. And now I messed up this morning with my students, and I told them if they had an overlapping area, then it didn't work. I am wrong. For an inequality that has an or in it, as long as you are satisfying one of the inequalities, then it works. So let's put in the notes. As long as one inequality satisfied. I don't know if satisfied is the most mathematical correct word to be using, but what I mean is if I take, let's say, the number -4, the value of -4, and plug it in, if I plug in -4, is -4 greater than 3? No, -4 is not greater than 3. 3 is a positive number. -4 is definitely not greater than a positive number. But is -4 less than 0? Yeah, -4 is less than 0. So it satisfies this one, but not this one. But that's okay because it just has to satisfy one or the other. Just has to satisfy one or the other. Even if they overlap. So an example where I messed up with my students this morning was I was talking about how things couldn't overlap, but they can overlap. So let's say I have an inequality that if I draw, I'm not going to be super strict about this, but this is a good note to have. Let's say I have this. I got this number line. I'm not going to put numbers on it. It's just random number line. And let's say I have an inequality that starts here and is going this direction. And then I have an inequality that starts here and is also going this direction. If I have this as an OR statement, if I say, actually, I am going to give them numbers. Let's say that this is 2, 1, 2, 3. So this is 5, maybe 1, 0, 3, 4. This, we only need to satisfy one of them. So if I plug in 2 into this, it works. If I plug in 3, it works. If I plug in 4, it works. If I plug in 5, it works. For this one, doesn't work for the red one, doesn't work for this other inequality. And right, my two inequalities are x is greater than 2 or x is greater than 5. As long as it works for this one, I don't care if it works for this one. So what you get is you get, again, don't know if this is the most mathematically correct thing to say, but you get something that overrides the other. So the actual graph of this inequality would be, oh, I shouldn't have filled that in. I should not have filled that in. That should be an open circle. That should be an open circle. Did it in black, Sharpie, no take backs. But you get a graph that overrides the other because everywhere in here, it satisfies this one, and then starting here, starting at 5, or actually starting greater than 5, it starts to satisfy both of them, which is fine. You can, if the statement is or, it can satisfy one or both. Actually, that's what we need to write in. I think that's the takeaway from all my gibberish I just spouted off, making this video extra long. One or both, a value can satisfy one or both. Let's write that down here. Running out of room in here. No. A value can satisfy one or both. Inequalities. Can satisfy one or both. And if it satisfies the main one, the one that overrides the other, then you're good. Okay? I think that'll make more sense if we just continue on. So let's continue on. Can't take back that 2 minutes of your life or 3 minutes of your life I just spent talking about that. My bad. So, example problems. What's the inequality? What's the compound inequality for this? My first question that I would ask students is, Is this an and? Based off of the graph representation, is this an and or is this an or? I would say it's an and. Based off of the notes we did up here, when and is in between two things, I would say that this is going to be an inequality that has to happen for both. Now, what's the quickest way to write this inequality? I think the quickest way to write this inequality is not like this first way. This is option 1. This is option 2. It's to write it like option 2, and you just take the numbers. I'm going to take -1. I'm going to take 4. I'm going to put x in the middle. Now, is x greater than -1, or is x greater than and equal to -1 is what you have to decide. And an open circle means that it is greater than. So x is greater than -1, and x is less than or equal to 4. All right, now that's option 1. Totally fine if you were to say -1 is less than x and x is less than or equal to 4. It's really separating it out. I prefer this for my students and myself. This is how I write inequalities when it's when it's inclusive. When we're talking about it has to be working for both. That's what I would go with. That's what I prefer. And I'm pretty sure most teachers would prefer that. This one, and or, number 2, I would say this is an or. All right, I'd say it's an or. There's nowhere on this graph where it's happening for both inequalities. So this one would be an or, and I would say this is x is less than -2 or x is greater than 1. Doesn't matter if you flip-flop this. You could say x is greater than 1 or x is less than -2. That's fine too. Totally fine. All right. Number 3, again, quickest way, just drop down the more negative number on the left, less negative number on the right, put x in between, less than, less than. All right, so this means that x is greater than -3, which it is, it's greater than -3, and this part means x is less than -1. X is less than -1, totally true, and you get that. Number 4, drop down the more negative number. 0 is less positive than 4 is. So we got 0 less than or equal to x less than or equal to 4. All right, I think that works pretty good. This is the quickest way to write it. I feel drop down the left number, drop down the right number, put an x in between, then fill in your symbols. They should always be pointing towards the smaller number, the more negative number. This one is definitely an or. All right, so we have x is less than -2 or x is greater than or equal to -1. All right, pretty quick. Now this is the tricky one. This is the tricky one. And this is what I got all caught up in the jibber jabber talking about when we're talking about ors. If I looked at this, I wouldn't think this is a compound inequality. If I looked at this, I would just assume that we're talking about x is greater than or equal to 3. That's what I would assume. And that's all you can. If you're given no other information as a student, if you're given no other information than this, that would be the answer. But what if I gave you a little bit more information? What if I was to come and put this on there? Now I have 2 separate inequalities that are being combined. And I know what the two separate inequalities are. So this would be x is greater than or equal to 3, or x is greater than or equal to 8. But what you see here is what I was talking about is one's overriding the other. Because you don't use two separate colors to graph this. Like you have one, you're combining them to be one inequality. You're combining them to be one inequality, not two. So when you actually graph this, and if you're given a graph of this, all you would see is that single line. That's all you would see. You would not see this other part. And you wouldn't even put a dot at 8. You see, I didn't put a dot at 8. I didn't put a closed circle at 8 because you don't need to. Because this x is greater than or equal to 3 overrides that. It's like if x is greater than 3, it obviously has to be greater than 8. Well, I mean, not obviously, but it includes everything less than 8, but is greater than or equal to 3. So you start here and continue on instead of starting here and continuing on. It overrides the other one. It overrides the other one. It overlaps the other one. However you want to think about it. Now, obviously, like I said, if all you were given was this and you didn't have another equation, I would want you to answer with x is greater than or equal to 3. And any teacher would. You don't have enough information to know it's a compounded inequality. But if you were to given that you have two inequalities and there's an overlap part, the graph of it would be which part is overriding the other. Which is, or if you think about it, which one begins sooner? Which one begins sooner? Which one has a sooner starting point, start from there, and then overlap the other thing? Take over the other thing. Hopefully that makes sense. I don't know, I'm trying to explain it multiple different ways because I know everybody thinks differently. I hate to be that teacher that just, this is how it is, think about it my way. So hopefully something about that stuck with you. But let's move on. Going to go through these pretty quickly because by now my expectation for my students would be that you know how to solve equations, and this is really no different. There's one difference, and I'll write that down right here. There's one single difference when solving an inequality than an equation with an equal sign, and that is when you multiply / divide by a negative number, you flip the symbol. All right, that is very important. When you multiply / divide by a negative number, you flip the symbol. That's the only difference. Besides that, you still do all your inverse operations, and that's what we're going to do. So in order to solve this equation, this inequality, divide by 2, divide by 2, you get x is greater than or equal to 1, or add 5, add 5, x is greater than 17. Now my expectation for my students is you'd be able to graph this, and I don't expect a super detailed graph. What I expect is for there to be 3 numbers on a number line when graphing. The first one would be 0. That has to be on the number line somewhere. And then we would put 0, and then 1 would be right next to that. And then over here, you'd have 17. Just so I know that they understand that positive numbers are on the right side of 0. All right. You should understand that too. So x is greater than or equal to 1. So before I graph directly on the number line, I'm just in case, I'm going to put some above. So x is greater than or equal to 1. Okay. And then this one says x is greater than 17. What do you know? I have exactly what I've been talking about. This is one that overlaps the other. It takes over the other one. It begins before. Now, this wouldn't work for and. This works for or. This works for or. Because as long as it's happening for at least one of them, as long as it's happening for at least one, you're good. So all the values starting at 1 and get greater than that work for at least one, if not both, but at least one of them. And then starting at 17, it starts to work for, or starting at 17, you know, anything greater than 17, it starts to work for both of them. But starting at 1, it at least works for this one. And then starting here, it works for that one. But this graph solutions that would work for this compound inequality. Okay, hopefully that makes sense. All right, so for when it says or, you only need your values to work for one or both of the inequalities that are being compounded. Doesn't work for this one, so let's do this one. Plus 5, plus 5. X is less than 7. And times 2 times 2. X is greater than or equal to 4. So if I draw my number line, again, I want 0, then we're going to put 4, then we can put 7. So the first one, X is less than 7. So open circle 7, less than 7. All right. And then this one says X is greater than or equal to 4. So close circle at 4, and then it's getting greater than. So when it says and, where is it working for both? All the values from here, from 4 and less than 7 work. So my graph would be starting here, and then I'd have an open circle at 7. And it'd be all of those points. Anything, any number I pick, starting at 4 and all the way up to 7, but not including 7, would work for both of them. Not just one. The difference here is all of the values in between here and here only work for X is greater than or equal to 1. And then all of a sudden, starting here works for both. Which is fine. And that's where I messed up at with my students this morning, was I forgot that it's okay when it says or for it to work for both. That's not exclusive to when it says and. And it is exclusive that it only works when it says both, when it is both. But when it says or, it can either work for one of them, in this case this one, or when it works for both of them, because then it's like, oh, great, it's working, it's nonstop working, it works no matter what. Over here, it at least works for one of them. Okay, moving on. So you got that. Here, we're going to divide by -3. Divide by -3. Cancels out. We're going to flip the symbol, because, why? We're going to flip the symbol because when you multiply or divide by a negative number, you flip the symbol. Oh, okay. I divided by -3. Flip the symbol. Don't forget. Or, then over here, -5, -5. Don't get confused minusing with dividing or multiplying by a negative. I get that looks like a little negative, but that's a minus. That's the reason when on a calculator there's a negative button and a minus button. They are different. So we get x is less than -2. Draw our minimalistic number line. 0, 4, -2. X is greater than 4. And then over here, we got x is less than -2. All right. Looks good to me. So that is actually exactly what I would graph, because over here, all of these values at least work for this one. And then here, all of these values at least work for that one. Now, unlike here, we don't have an area where it works for both, but it's totally fine. These ones, this over here, it works for this one. Over here, it works for that one. Totally good. Totally fine. Because when it says or, it only needs to work for at least one. Okay. +2, +2. And I don't know if I'm yelling or not. I'm used to wearing my mask all the time this school year, so I have to yell through my mask. So do forgive me. Okay. And divide by 2 here, divide by 2 here. Get x is greater than 4 there. All right, we're going to get our number line going. So we get our number line, 0, 3, 4. So let's find out. We got to first graph it above. Don't just assume, graph it above. So x is less than 3. So that's here, less than 3. All right, looks good. X is greater than 4. Okay, that looks good. Wait a minute. Wait a minute. It says and. It says and. We got a problem. We got a problem, right? There's nowhere where it overlaps. There's nowhere where these inequalities are graphed where these solutions work for both. These values over here work for this inequality. These values over here work for this inequality. There's nowhere where the values work for both of them. What happens? No solution. And hopefully, if you're watching this, you understand what you've done some problems where you've gotten no solution. I know my students have. So this one would be no solution. It does not work. These cannot be put together. It doesn't make any sense. There is no solution to that. This here makes sense because x can be less than 7 and greater than 4. 6 is less than 7 and 6 is greater than 4. That makes sense. This does not make sense. You can't be less than 3. You can't have a number that's less than 3 but greater than 4. There is no number that's less than 3 than greater than 4. There's no solution. All right. Now, what I want to spot out here is, you see how 8 and 10 are written, they're combined, they're and inequalities, but they're written out separately. Now we're going to look at 2 more examples and this video is over. We're going to look at how to solve compound inequalities that are combined with the word and, where it needs to satisfy both of them at the same time, that are written as a single inequality. They don't have the word and in between them. They're written as one inequality, just like these ones. Well, how do you solve these ones? So what I want to go back to, this is the example I use of when you had an equation and your teacher was telling you to, what you do to one side, you do to the other, or if you do it to the left side, you do it to the right side. You had a left and a right. There is a left and a right side of an equal sign. right? Fair enough. Yeah. Okay. And even if I go back here, if I go back to the inequalities we were just doing, and I was solving this, wasn't there a left and a right side over here too? Yeah, there's left and a right side. If I divided by 2 over here on the left, I divided by 2 over here on the right. And what separated the sides? The inequality symbol separated them. And in the case of an equal sign, the equal sign separated them. Well, here, I have an inequality here, and I have an inequality here. So do I have a left and a right? Sure, but I also have a middle. So what I do to the middle, I have to do to the left and the right. Because your teacher shouldn't be saying what you do to the left and the right. What you do to the left, you need to do to the right. It should be what you do to one side or to one thing. I like to say one side, you do to all the sides. Sometimes there's more than one other side. This case, there's 2 other sides I need to do it to. So when I need to get x by itself, I need to get rid of this plus 2. So I inverse operations, what's the inverse of adding? Subtracting, so minus 2. But I need to do that to all 3 sides. So that cancels out. The whole point of this is I'm getting x by itself. I'm going to drop down my symbols. What is negative 3 minus 2? Well, that's negative 5. What is 10 minus 2? Well, that is 8. And then it's really easy to graph from there. Super easy. Like I said, I like to graph from these ones. You know, there's no question that this one's going to work out. When they're written like this, they work out because you just have this. You got negative 5 here. Let's throw 0 in the middle. You got 8 over here. You literally just copy straight down from here. I got a closed circle at negative 5. I got an open circle at 8. It's everything in between. I am a fan of when they are written like this. You don't need to check them. You just need to solve them and then take the more negative number, drop it down, more positive number, drop it down, fill in between. All right. So same thing here. I'm going to divide up the sections. So I need to subtract 5, subtract 5, subtract 5. Cancels out. I get 5 is less than 5x is less than or equal to 15. Now I need to divide by 5, divide by 5, divide by 5. Cancels out. Continue this a little bit down. So I get, what's 5 divided by 5? It's not 0. Don't ever do that. 5, anything divided by itself is 1. And then same thing here, 5 divided by 5 is 1, so I'm left with 1x. And then less than or equal to 15 divided by 5 is 3. Like I said, it should work out perfect. So I just draw my number line, 0's over here, and then 1, and then 3. Open circle, closed circle, in between. All right, I definitely think this video is long enough. Definitely think it's long enough. So I'm going to end it there. I do hope this is helpful. I know it got a little bit confusing at the beginning. I kind of got caught up in the explanation. But thank you for sticking with it. If you did, I appreciate it. And I hope you have a nice day.